Great. So thank you everyone for dropping by. I believe that this is going to be an interesting session, and we're trying this as a first meetup to be done virtually for Elastic community in APAC. And that too an interesting topic, Elasticsearch and Kubernetes. So that being said, I'll introduce myself, who I am, what I do, and probably some of you might be knowing very well sometime. And also, like, we'll be looking in deep into some of these Kubernetes and Elasticsearch concepts, and also like we'll see a demo at the end. So I'm Arvind, and I work as a developer advocate for Elastic. I run the meetups for APAC. In general, like a lot of places I've visited. I kind of like speak at affinity groups, conferences, etc. You can reach me out on Twitter or any of these places for questions. There's a Discuss forum that we maintain for all the questions related to Elastic, discuss.elastic.co. You can write your questions there as well so that we could answer. So coming to the topic, like today we are discussing about search. So search is a constant foundation for anything and everything that we do. A bunch of examples that we see Elasticsearch or search in general today is like probably where if you have taken an Uber today morning or at some point of time and trying to find a cab to go to the place where you want to go. So that is a search request on top of a geographical or a data, which literally brings and pairs you up with a specific driver. Similarly, if you are trying to look at restaurants and like try to find out the favorite food or the restaurant, or probably trying to look onto specific the filters, etc. So, or find a specific time period where the restaurant is open. So everything is a search request in this case as well. Similarly, if you are looking at your specific area, like you are looking to find a partner, when you do left swipe or right swipe, I mean, Tinder is the one that matches you with a specific partner, but it's literally a search request that helps you to find a specific partner according to the choices. So there are many such experiences like that, like a regular search bar to something that you do unknowingly or type unknowingly and find out things. So everything is a search, and search plays a vital role in your application experience, as well as in doing many things like these. So imagine search not being there for all of these applications that you use. You might feel that there's a lot of data, but you'll not be able to find what and where and how this data is present, and how these things are covered automatically. So Elasticsearch is a really popular search solution that is deployed across various industries, segments, and geographies for different use cases. So it is one point solution to do many things like streaming analytics, search engine, etc. So there are a bunch of use cases in all of these segments, industries. You can also go and look at our website for knowing more about specific area. But today we are going to look at the stack and how it is being deployed, more on the topic of how it is being deployed, how you can scale this. So like I said, search is a constant foundation, whether you are looking at a bar graph or probably doing machine learning. You are literally searching through the data to find answers. I mean, even if you are using a SQL database, you are literally searching because when you do select star from EMP, you are literally trying to fetch all the data that is there in EMP, or probably do a where clause and find out where the specific search results are. So Elastic Stack, also known as ELK in popular areas like developer circles, Elasticsearch, Logstash, Kibana is very well known for ops and logging, etc. So nowadays called Elastic Stack. But what is this Elastic Stack, and what are the components that are there? So Elasticsearch is a distributed NoSQL search engine which is open, or the core of it is open under Apache 2.0 license. And Kibana is a visualizer which sits on the top, which helps you to visualize what's there in Elasticsearch. Then you also have Beats and Logstash, which is the ingest technology which helps you put data into Elasticsearch. So for everything and anything, Elasticsearch is the heart and soul. which helps you to solve all of these use cases. So each of them are an individual project. Elasticsearch is a distributed system. That means it needs to be run in a cluster or a node based. I mean, each node will be running Elasticsearch as a process. Then you have Kibana, which can connect to this cluster and show what is being happening on this data. So end of the day, you can run all of this platform in one or the other way. Anyway, we're going to discuss more about that particular thing. So I'll keep that at the later slides. So at the same time, we will dig a bit deeper into Elasticsearch and understand how various areas are, various specific features of these. Like I spoke about distributed and scalable nature of Elasticsearch, it's also highly available because of the concept called shards, which I'll also show you in some slides. It also helps you to do multi-tenancy. It's very developer friendly because everything is an API here. You have YAML as a configuration language across the board. That means like with any of these products, you can write a YAML file and start configuring things. So you would find under the config folder of each of these projects, like being Elasticsearch, be it Elasticsearch, Kibana, Beats, or Logstash. For everything, YAML is a configuration file. At the same time, it's a full search engine. That means you can ask an abstract question and it will rank and find out relevant result set based on the question that you have asked, and then kind of like show you the fully blown experience of exact like a search engine. Now that being said, the different angle of ops are probably looking at a health of health of a platform and various other things comes in when we talk about aggregations framework. So there is a different sort of aggregations. Aggregations is nothing like but your group by. So you can do analytics using or do number crunching on top using aggregations. There are multiple aggregations which does categorizations, which does find out trends, which can help you in find out doing something like a pie chart. So there are a bunch of stuff which helps you to do all of this. So everything real time in place in a single shot, all through an API. So that is the beauty of the Elasticsearch. That's what we are currently looking at deploying these. So, but this is not specifically, we are not again to re-emphasize on what we are doing today. So we are not specifically looking at learning these features of Elasticsearch. We are specifically looking at deploying these in a scalable platform like Kubernetes actually. So for example, if I have to talk about the distributed nature or how things work in Elasticsearch, you have think of having a 3-node cluster. So each node being anything like think of having it like a VM, right? On a Google Compute Engine VM or probably EC2 VM or Azure VM. I'm talking about the clouds, or probably a bare metal machine where JRE is installed and where you have Elasticsearch running as a process on top of it. So each of this, when that happens, each of this is called as Elasticsearch node. When all of this work together to form a common cluster, we call it as a 3-node cluster, 4-node cluster, or depends on the number of nodes, we will call that as such. So here, if you see, I have small colored bars, which are called as indexes in Elasticsearch. So each index can be present in like multiple nodes, not restricted to any single node. So it's a distributed platform. The data is distributed across as well. So that being said, like I mentioned before about the scalability, etc., or highly available solution. So shards are the ones that are present under each index and help you achieve this fault tolerance and high availability, and also gets you this throughput, etc. So these are the basic concepts in general when you are looking at running Elasticsearch on an infrastructure platform, be it a cloud provider or be it anything. But of late, like there are a bunch of ways that you could deploy Elasticsearch or this solution and do many things. So, for example, Kubernetes. Kubernetes is a container orchestration platform, where open sourced by Google in I believe 2015, and there are a bunch of other open source as well as proprietary orchestration layer platforms, which also orchestrate clusters and do a lot of these things. But Kubernetes turns out to be an undisputed leader in container orchestration. It helps you to do a lot of these things. So it's also a go-to platform for your microservices-based architecture. Suppose if you have a tech stack which is divided into multiple services, say that you have a React front end and you also have maybe a Node.js backend, and you also have Java for some APIs, and then you have Python for data science, and or some lookup store. If you want to scale up, scale down all of these services individually, also maintain, monitor, manage all of these services, you need a platform which helps you to do individually by keeping the modularness of all of this. Kubernetes is a very useful platform for microservices based architecture. Essentially, a lot of people use Elasticsearch, Beats, and Kibana to collect information from these microservices and do monitoring of microservices as well. So that is another angle which we are not going to discuss today. We are going to discuss about running Elasticsearch on Kubernetes again. So obviously there are a bunch of implementations or flavors that are there, which helps you to kind of like run Kubernetes on their cloud platforms. Like Google has its own version called Google's Kubernetes engine, otherwise called as GKE. Then you also have Amazon's I believe EKS, Elastic Kubernetes Service. Then you also have Azure's Kubernetes Service. All of them are implementations of Kubernetes running for scale in a public cloud environment. But also you have platforms like OpenShift, which are very popular as well, which is run by Red Hat, and which is also like a Kubernetes distribution, which helps you to run, orchestrate, and manage these in your private cloud environment as well. So Elasticsearch can be deployed anywhere because of the containers nature. But because we are talking about Kubernetes more, and because we are going to talk more about the lingo or the jargons in Kubernetes world, I thought that I would give you a brief outro to Kubernetes. Of course, there is no end for the knowledge in Kubernetes because it is really, it's kind of really exhaustive. The technology is like very, more and more, getting more and more features nowadays. So we'll see the overall architecture, etc., and helps you to like find out what's in the store. So in the nutshell, there are a bunch of resources that we definitely need to know when we look at Kubernetes. Like, for example, Kubernetes help you run pods, which are a group of containers. Group of containers is called pods, and you have multiple nodes. These nodes are VMs. You can think of it like a VMs, and these nodes again act together, like run these pods, and just like any other distributed system. And you have multiple pods, and you have namespaces, etc., etc. So, and you can deploy services and access those services using the regular TCP protocol. So, for example, if you have a payment service, you can spread those containers, the code of payment service, into multiple nodes and expose that as a service to the external world. And then it can automatically do a bit of load balancing, running it in a use the distributed features of Kubernetes, etc. And you can also scale it in a multiple node fashion, where you have multiple pods, multiple containers, etc., etc. So all of this is definitely a resources based approach of Kubernetes. You can also mount volumes and also secrets into pods. For example, if you have a specific service, name a cloud service that you are connecting through a container. Suppose you are writing the data that is being received from the user to a cloud storage bucket. Then you definitely need a OAuth key or a specific API ID. You can call it as a secret and store it in a key store kind of environment, and it will be loaded onto the pod securely. Similarly, if you have specific sort of volumes, say that if you want to add persistent volume or like SSDs, or you want to add HDD or specific sort of network drives, you can add. So everything is in modular, everything is in a declarative fashion as well. So when I talk about declaration, I'll also explain about what is declarative nature here. So till now we have seen the diagram of Kubernetes, but this is something like a text file or a YAML, which is also a configuration file for Kubernetes. So what it does is like you just tell in this particular YAML file, and it automatically implements the changes that you mentioned. For example, if you are seeing here as deploy this example app, label or tag the app with example hyphen app, the container is coming from this particular container registry. So GCR is Google Container Registry. You might also have your custom or your custom registry, custom like you can do all of that as well. And then the name of the container is test container. The resources limit is 1 GB, 1 gig, or you can also add a bunch of these volumes. Similarly, this is a prescript for service. This is a prescript for the secret. So everything is declarative. Everything is in a schema, well-defined schema, and you just need to apply that over to the Kubernetes. So where do you apply? We'll also talk about that a bit. So the reason why explaining a brief information about Kubernetes, that because we're gonna know, if you know more about this, then we'll understand like why we need to run, how we need to run, and what are the things that we need to look at when you're running Kubernetes on Elasticsearch on Kubernetes actually. So there are many more resources that are exist like deployment, daemon sets. Daemon sets are kind of like a bunch of services or binary that is running on all nodes. So for example, you can deploy beats as daemon set. That means like file beat, metric beat, packet beat, all of them can be run as a daemon set to prune or get all the logs and container logs, system logs, everything, and like ship out to do monitoring, etc. You can also attach persistent volumes. A stateful set is very important at this point, look, because Kubernetes is kind of like a, a stateless machine, wherein earlier a stateless machine where you don't have the state is maintained by another system. So later when they have put up this stateful set as a feature where you can define a custom controller to kind of like look into all of these states, etc. So stateful set is a feature that has been implemented at a later point of time, and that helps us to run distributed systems like Elasticsearch or many other distributed system which needs which are stateful and which share some data in between multiple nodes. So in a nutshell, like again, talking about the architecture, the Kubernetes has multiple components here. We will go through one and other component. I think we already spoke about nodes, but talking about like etcd. So etcd is like a key value store, but again, distributed key value store. You can have one node or you can have multiple nodes. So again, it shares the data. Actually, it also has a watch mechanism, like alert mechanism. It stores all the KS resource files or the things in a specific in the etcd place, and it helps you. It acts like a store where the API server or controllers can query and get data and know the state, etc. So it's like a data store. etcd is like very popular as a key value store. It's a CNCF project as well, just like Kubernetes. So similarly, API server contains a bunch of APIs. So this is what when we are looking at kubectl, that's like an CLI to interact with Kubernetes. So it's literally interacting with your API server. So API server helps you when you give a command, or when you say that I apply a specific YAML file, I am applying it on an API server, calling an API with a specific sort of a structure, and then it helps you to like kind of delegate that request to one of these controller, and controller will also act on these nodes, etc. So the user, obviously like us, we interact with the kubectl using the kubectl. Then we also have kubelets, which is like an agent which runs on each node, watches the pods, and sometimes manages the corresponding containers on the host, helping in maintaining the replica sets. I mean, suppose if a service is stopped and you want to restart. So there are many such features that are available in Kubernetes or the overall architecture, which helps us do that. But controllers is very important thing that we are looking at this point of time, because the controller is the one that helps us deploy a stateful system like Elasticsearch. So there are multiple controllers which help run resources in a proper way, which orchestrate all of this infrastructure like containers. So there are controllers for each and every action. Suppose for container orchestration, for maintaining specific state in the APM server. So all of this is a specific, each and everything is a controller. So you might want to go and read about more about controllers, because it's very interesting, and like you can also probably write a custom controller to manage your own application as well, which might be available open source as well. So you please go and look at more about controllers. So controllers contains logic to process the application or the resources. So there are some existing controllers in Kubernetes, like scheduler, which watches the pods. There's a replication controller, which maintains the, like I said, whether certain number of replicas of the container is present in the Kubernetes cluster or not. There are many controllers which are specific to each cloud provider as well. Cloud providers, when they say Kubernetes engine, they are having a custom Kubernetes. That means that they have control over how the Kubernetes is being run in a production environment. So we are essentially looking at these controllers, and which helps us solve multiple of these problems. So now that you get a feel of like, okay, Kubernetes literally is like mega scale. This is where I should run any of these applications. But still, the stigma of like, okay, don't deploy applications on a Friday, because I don't know whether it would run, or there are still a lot of talking points around Kubernetes, when even though it is a go-to platform, there are many, because of its massive scale, sometimes things are also like really tricky to manage. So that's when people from CNCF and a bunch of folks came and like introduced this something called Helm. So Helm is a package manager for Kubernetes. Why I'm talking about Helm also explains another topic, which is coming in few slides. So Helm is like your, Helm is like your NPM, or something that manages your app, not your applications, but the installation, creation, or version management of your application. It is not something that exactly deals in your internals of your application. It is something that helps you manage the version. So we also have an official Helm chart if you want to install, and these Helm charts are supported, so you can go and look at them as well in the particular GitHub repo. So that being said, Helm charts are there, but how do I manage my application inside Kubernetes, and how different is it from doing a Helm chart or something like that? So Core OS, the company behind the container OS platform, the Core OS, which is a very popular container distribution. So they have come up with something called an operator framework, a SDK, which helps you to build this particular operators for general purpose applications. So for example, you have Nginx. Forget about Elasticsearch for a while, you have Nginx. So if you want to run Nginx in Kubernetes, and obviously you could deploy it as a container to your services and run stuff, but you might also want to do some smaller or bigger operations which are very specific to Nginx, like managing some rules, attaching some IPs, connecting to some security systems. So all of these are custom stuff to Nginx, and are not related, or can be managed by your plain vanilla Kubernetes, right? Kubernetes is not built to do that. Kubernetes is just built to manage your containers, and meant to run these services and give you that kind of like luxury of running it forever in a desired state, right? But operator framework brings in that luxury of running a general purpose application in a much automated, orchestrated fashion. That means like, suppose if you have a MySQL and you want to run MySQL cluster in a distributed framework, if you have heard of VITES, VITESS, distributed or a scalable MySQL platform, you can run backups, you can automate backups, you can kind of like do upgrades of MySQL cluster. So a lot of this is possible because of the operator. So again, Helm is operator. So in general stack perspective, if you go and look at all of this, you have an operating system, binaries, config folder, a package manager, and a configuration manager. So similarly, if you're looking at the operator Helm, same area, so you could look at Kubernetes and a bunch of images of Kubernetes, then the objects, and Helm, and like bunch of other Helm files, Armada, etc. So, but operator is very native to Kubernetes. That means like operators are applications which run and which are should be managed internally to Kubernetes, not from external area. So Helm plays in a role where you kind of like run the start, run the versioning system. Maybe if you have a CI/CD, and it helps you to manage these packages, etc. But Helm doesn't manage your application inside your Kubernetes. So that is the overall gist of like Helm versus operator. So operator framework is very famous. Like you got a operatorhub.io, you can go back and look at all of these operators that are running. Obviously we have done an operator. That's why we were doing this talk today, because we have an official way to run Elasticsearch on Kubernetes. So Elastic Cloud on Kubernetes is the operator that we have. The code is open. You can go and look at it. You can go and submit PRs, issues, whatever, or please give us feedback on things like how do you are looking to support a specific Kubernetes version or a bug in a specific version that you want to solve. So you can go and log it, and our engineers would definitely love to answer them. So the operator hub is the official way to go and look at for official operators. And there are several other operators for each of the general purpose application like operators. Like operator hub is the one that you should go and look at if you want a specific operator. Now, that being said, let's go and talk about deploying these Elasticsearch. Now, we'll take a step backward again before talking about Kubernetes. So there are a bunch of ways that you could still deploy. We are not suggesting or telling that Kubernetes is the only way to deploy Elasticsearch. You can download this one and run it on your own laptop, or which you would not do for production environment. Maybe I think that you could run it on your bare metal or a data center. Then you can also run it on a cloud infra, like an infrastructure on any public cloud. You could also run it on a managed service like Elastic Cloud, wherein you just need to solve your business problem, and like the cluster gets deployed. By the way, we also use a container orchestration based platform for running our managed service, which is very custom to us, but which is like a managed service, and you just need to have the API endpoint, etc. Now, obviously, like you can run Elasticsearch on containers, and you can simply say Docker pull Elasticsearch, and you would get Elasticsearch as a binary, and you can start running. But this is where the Kubernetes comes to rescue, wherein if you want to scale, manage, orchestrate, you have Elastic Cloud on Kubernetes. So why we call it as Elastic Cloud is you can, when you're running it like a service, Elasticsearch as a service, and on the Kubernetes. So what it does is like it has custom resource definitions. That means like just how we spoke about resources a while ago, pods, deployments, services, etc. Similarly, if you want to deploy Elasticsearch or create Elasticsearch, like kubectl get Elasticsearch, or kubectl get Elasticsearch log. So if you have if you want to call Elasticsearch as a resource, you can do that. You can do custom using custom resource definitions. You can do this thing actually, but we provide an automated way to do all of this for you in a very easy manner. So there are a bunch of like controllers which helps you to do all of this. You can also automate tasks. So one another important thing that you need to understand is like the cluster by default when you deploy through Elastic Cloud ECK. Okay, let's call it as ECK for the ease of use. Is like the TLS certificates, the secrets, and security by default is enabled. We manage that, and security is a free feature from 6.8 and 7.1. So if you deploy anything in this area, so 6.8 in 6.x series, and like anything above 7.1 and 7.x series, you would definitely kind of like be able to like run this thing actually. So don't think that security is a paid feature. So go ahead and use security. You can't disable the TLS or security in the default cluster of Elasticsearch. You might be able to disable in other areas, but not here. So that is something that we are like really looking at. We want everything to be secure when you're deploying it on a cloud resource. So there are a few commands which helps you to do it simply. So this particular commands that you're looking at downloads all-in-one YAML, the resource set in a single shot, and then like also deploy a one node cluster on Elasticsearch. So if you see here, we are talking about Elasticsearch as such. and kind of like deploying this on a Kubernetes cluster and running it as a as a service. So I'll briefly, I mean, obviously, like end of the day, while we talk all of this technology, cool technology, but the real deal comes in when you demonstrate it. And I'm a huge believer of demos. Like I've submitted my prayers to the demo gods today. I hope that I'll be able to showcase some of these today. So this is the repo. If you want to go and take a look, the repo is available and it tells you all of the latest versions that are supported. So please make sure that you take a look at this repo also. There is a documentation that you could definitely kind of go and look at it. So you can do that as well. So, okay, bingo, great. So I think that there is some problem in kind of like deploying a Kubernetes cluster on GKE. Not a problem. So I think I am out of my used addresses on the GKE cluster. No worries. I have a Docker for Mac. So if you see here, okay, let me go and look at it. So I have a Docker for Kubernetes desktop running. So Docker today, Docker desktop today supplies you all of this like Kubernetes by default. It is giving 1.14.6 cluster. So you could go ahead and like deploy it using that. My preference would be running it on a specific cluster like GKE or any other thing. But unfortunately, I think that I don't have a bunch of IPs. So before getting to go, I would just simply run to see whether kubectl. I hope that each one of you might be very much aware of Kubernetes, some of this lingo, because it might be very difficult to understand if you're not. So I'll try to make it as simple as possible as well. So you have Kubernetes master, kubedns that is running, which helps you to assign various stuff. So kubectl is a command to find out various things with Kubernetes. So I would also say kubectl get pods, no resources found, get svc. There's Kubernetes that is running. You also have what else? Yeah, you also have deployments. So there are no resources found. So now let us clear off and deploy the Elasticsearch. Create this particular thing. So this creates the resources that are much needed. So which would act as your operator. So operator, as I said, is a bunch of controllers that are in play to manage your the entire Kubernetes cluster. So I would show you the logs. So before we go ahead and do something, so suppose you could see that there's a custom namespace called Elastic System that we have created. There are a bunch of controllers like APM association controller, Kibana controller, trial controller, APM server controller, Elasticsearch controller. Each controller has a specific processing logic. When you ask to deploy, this controller logs will come and play a role in like kind of doing all of this. Okay, let me close this. Oh, what happened? Great. So here, if we have a bunch of we have already added this specific YAML. So let me go and deploy the Elasticsearch deployment. I would walk you through this particular thing so that you would not see it like a French or Greek, and you would probably understand this. So if you see the kind is Elasticsearch, it is not a container or a VM or something else. We have created a custom resource, and that's why we were able to call kind as Elasticsearch so that Kubernetes API server would understand it. And you also have, we have giving the cluster name as quick start. So this would prefix all of the things that are deployed on Kubernetes cluster. So if you want to have a name change, you can also change the name and put it as like your own custom name as well. So this is a version, the version spec, etc., etc. So there is one more other thing that we are looking here is like we don't need a load balancer as such, through which you need to like kind of run this entire stuff. So I would probably delete this. I would copy it and delete this so that because we are not running it in a public cloud environment, So we don't need a load balancer as such. So we can deploy a vanilla Elasticsearch deployment as well. So these are the spec that you would change if you want to do anything specific. Suppose I was doing a search demo previously, and then I have an action auto create index. This will go into your Elasticsearch YAML. So these are also the settings that are going into your Elasticsearch YAML. Now that I have node count as 1, I will also make it as 3 and deploy 3 nodes with all these parameters as such. So that and all is definitely possible. And let me try to deploy this. So it says Elasticsearch quick start created. It's really fast because maybe it's running on my local machine, but in cloud you might get a bit of delay because all of this needs to be created as well. So it says pod is initializing. You can also look at the details like okay, the pod is already running. So you can also see the details like this, and you can also see what sort of services that are being run. So it already created a quick start ES HTTP service on the specific IP. So if I created, it takes a cluster IP as a service. If I created a load balancer based thing, it will show load balancer and it will also show external IP. Because I don't have that, it is not showing, and it is showing that we are running Elasticsearch on 9200. So that is one thing. You can obviously like do this particular thing like kubectl get Elasticsearch, which looks like really native. It shows a custom command. This is coming from an API server. It talks to our controller and gets you all of these details. Then I've shown you the logs. Obviously, you could go and look at logs. We'll see something else as well. The important part here to be noted is the security. So we have automated the security part. So it is stored as a secret in the Kubernetes environment. So let us go and quickly look at the password that is being presented here. So this is a password that we randomly generate, and you could also store it in the environment variable with respect to that particular that shell. Obviously, if you store it permanently in your bash shell or probably in your resource config, it would be much easier. Okay, let me go and do this thing. Great. So I have the password. Let me find out if I could do a curl call on top of the same thing. Okay, fine, no problem. So I'll just try to get the service name or localhost. I'll probably do localhost. That is easier. So because it is running on my like local machine, so I don't think I need anything specifically. So it says cluster refuse. That's great. Okay, it says due to some reason it is not connected. Let us try to see if I could run it on my okay. Great. So due to some reason, it is not connecting to the local host. Maybe I need to port forward this particular service, which I have not done. We could also do the port forward and or else we could also log into this pod. So let us see kubectl get pods. You would get this pod. If I say I hope that I'll be able to log in. Okay, fine. No, let's not experiment. So basically the service is running. I just need to do port forward of the service into a specific area so that I'd be able to get. So all of this is available in general. If you want to deploy this, you would be able to run this from the quick start. This entire playbook, whatever I'm running is from quick start, which is like the cloud, which is the documentation for doing everything. So you could look at the same. I've just made some modifications for the specific public cloud environment as well. So if I have to do port forward, I'd simply do this and see if it could work. Okay, so I could simply go ahead and type localhost. it asks me like it can potentially ask me a username password, and then like maybe I need to give that. Yeah, advanced, proceed to localhost unsafe. So if say elastic, oh shit, say elastic, and then I need to capture that particular username and this thing, and then show it to you actually. So which is like a tricky thing. I just need to show the so I've got this. Then let us put forward again so that okay, it has come up because great. So now that you got the Elasticsearch cluster running, you will be able to do all sort of queries, APIs, etc., etc. So you would be able to find out what are the indices that are there, because there is nothing. It is not showing anything, but you'll be able to see the indices, etc., etc. So all of this is like very, very interesting. You could also deploy a Kibana. So I have a Kibana playbook as well. So if you could, this is a YAML file again, you could put this in a YAML file and deploy it automatically. So again, I don't have a load balancer. I don't want to deploy a load balancer. So I would simply go off and deploy it by default. But this one would be, I think it would be automatically exposed because it's Kibana. So let me, it is exposed on 5601, and let me deploy this and see if I could do that. So Kibana got created. Let's see kubectl get svc. We got Kibana. Let's see if this works. Curl. Okay. Hyphen u. Okay. The environment variable is stored only there, so that's why it might not work. But in this case, I believe that we still have something here. So I use a bunch of demos, and probably due to some reason, sometimes it might not open up or work. But so that's the reason. But the Kibana has been deployed, and you can also put forward or kind of like expose the service over a load balancer in a public cloud and like start accessing Kibana as well. So that can be done as well. So there are a bunch of ways to do all of this. So ideally, what I would do is like post the data into Kibana control and like run this playbook and like see connect to a UI and then test all of this automatically. So let me try to do this. So I have. So the Kibana is not up yet. It takes a bit of time to kind of like start working. Maybe it is also due to the kind of like the password parameter, which is not there here. So it might be a bunch of reasons. So we are not going to debug that as well. So the resources has been deployed. You can manage all of this. You can look at doing upgrades. You can do custom templating as well. So on the cloud on K8s, you have a detailed explanation of the features. But if you want to look at like the documentation, this is the place to go. You also have resources on like how to access these services, specifically like how to get the secret, how do I store a custom certificate, how do I allow public access to this machine, like managing your self-signed certificates. So all of this is definitely there, so that if you have a custom domain and you want to make it like if you want to make it as an internal service, you can do that as well. So you could also give it the custom templates like let me show you. So if you have a specific requirement to run 2 GB node, obviously everyone will not run with the defaults. You need to run with a custom heap, custom disk. You can do all of that. You can also attach persistent volumes. You can also do a bunch of stuff along with all of these details. So that being said, that's the demo that I am planning, that I look forward to show you. There is also a search UI that we have done like in some time back. So which is very interesting to attach to any of these the search engine, and lets you access deal things. So if you're running on a Kubernetes and you just want to quickly show it to people that how easy it is to run stuff, so this way you could probably like spin up a Node.js application and like start using stuff. Now I see some questions. I know this is very difficult sometimes. Like this is very difficult. I'm looking forward to kind of like look at questions as well. Okay, the question is about, I'm having can you elaborate more on why we use operators? And second question about SS certificates of Elasticsearch, like integrated with SearchGuard with Elasticsearch. So, okay. So the Q&A panel helps you to submit questions. So please ask questions there only. So that helps us track and answer the questions much better. So basically, like why we use operators, because I explained the entire story. Because operators are manages your internal application state, a bunch of controllers, which helps you to deploy an application like a Kube native application. So the application which is like very native to Kubernetes. So that is why we use operators. We don't use Helm charts or something else because of that specific reason. So let me just first of all like stop the share and like try to take more questions as well. Great. So basically, so that is the reason that we use like the operators as such. So the another question is like, can you configure SSL certificates, which is by default given? So I don't think you need to use any other tool to do all of this. So I would request you to read a bit of our blog, a latest blog about all the latest updates related to everything related to security as well. So that is the basic reason. Yeah. So please look at the security is anyway free, so you no need to work on creating a custom certificate, etc. So another question from Chetan. There are a bunch of questions, answer everything. So it's like Elasticsearch is a replacement for of MongoDB for a small scale project. So it definitely depends what sort of use case. Elasticsearch can definitely Elasticsearch can definitely be like used on replacement for a bunch of NoSQL data stores, because it can act as your primary data store as well, provided you need to configure all of your disaster recovery, everything. So yeah. So another question is like about auth layer. Security is present, so you don't need to add custom auth layer. So yeah. So kind of like it's not needed. So please see that it's already there. So the username, and you would need to definitely give the username password to stuff. So auth layer is already there. Is it possible to test and run Kubernetes on my laptop? How to get started? I think I've demonstrated same thing. I'm running a MacBook Pro, and I have Docker for desktop, and I have ran Kubernetes on my laptop as well. So you could also try and run this. The quick start help you to do that as well. You can install, if not Docker, you could install Minikube, which is also like a small Kubernetes. So how are ECK and ECE on-prem different? So ECE is a large scale orchestrator, which helps you to manage herd clusters. So you don't need to manage them. It can be deployed. It helps you to manage multi-AZ configurations. Like suppose you have multiple regions, multiple availability zones, talking about cloud or on-prem or hybrid. So ECE is your orchestration layer that is built on to do many things. ECK is for one cluster. If I have to tell about Elasticsearch, Elastic Cloud and Kubernetes, so it is like you are running one cluster, one service. If you are running mega scale, much more than that, you do that. So we look forward to do more integration on ECK and ECE, like probably managing a Kubernetes cluster through EC, and by default, like you would be able to start the trial, like get all the features and look into everything. Yeah, if you have more questions, please write to us. I think I kind of like have I kind of like have some links to show you before we leave that as well. So GitHub link for sample application for Elastic and Kubernetes. So this is another question from Sandeep. So I think I don't have a sample application that I have deployed. So this is we are running Elasticsearch on Kubernetes. Elasticsearch is the application itself, and that I hope that you are asking about something very similar. So quick start is kind of like the thing. So regarding all the integrations, another question related to like the integration between Elasticsearch and Keycloak, I think it is there, I believe. So it is probably one sort of mechanism to authenticate some of these things. I'm not really sure specifically about some services. Probably you could ask on the Discuss forum, and like I'll get back to you, or you can ask anywhere as well. There is another question about how can I take health monitoring for Elasticsearch. So Elasticsearch by default gives you this kind of what you call Elasticsearch by default gives you this monitoring you can do through Kibana. So you can, it also exposes a API endpoint cluster underscore stats at cluster level, index level, or any sort of resource as well. So you could go and get the stats, but we have a monitoring. So you could do one cluster monitoring for free. So you can enable monitoring and start looking at graphs, how the searches are being spiked up, various things, not just one, various things. You can do all of that as well. So that's about how do you do health monitoring. So another question from Sandeep Kanavar, like where in Elasticsearch, okay, it's an answer. Thanks for answering. Probably like, yeah, this is how the community works. Maybe like you're answering them yourself. So Discuss forum link is like discuss.elastic.co. So I would share some resources with all of you so that you can probably go back and get like more details on Elasticsearch. So there's a specific link that you would share. So if you are looking to get more details on each of this topic, all the resources, webinars, or the concepts that I covered, my email address, everything is present at this link. We would also share this presentation. It's already up on my slides, so that will also be there as well. So don't need to worry about the presentation as well. So any more questions? So I didn't check. Yeah, if you have any more questions, we can take questions. Yeah. Let me stop here. I don't know why the Q&A. So I mean, you be to Elasticsearch and want to run Elastic. So there is a meetup that we run in Pune. There are a bunch of people who are from Pune who are here as well. I think I could see from the community. Pune Elasticsearch meetup is the meetup that you would probably like go and attend if you want to attend, meet our community physically. Yeah, that's the physical meetup that we have. We have a bunch of plans for next meetups. That being said, we want to bring in the best. I would also leave things for Ning to add in our community team so that can help you better. Over to you, Ning.
Thanks, Arvind. So we will be sharing the recording after this session. We'll share it to the email address that you keyed in when registering for this session. I think other than that, we are also looking for speakers. If you are enthusiastic about Elastic or you have an interesting use case, please email us at meetups@elastic.co, and we can work together to have you share in our next virtual meetup. So I think that's all for now. I don't see any more questions, so I'll be ending the session now.
Thank you for joining.
Thank you.